Collision. First of all, we should know, in collision, the contact of the body is not very essential. If the bodies do not touch each other, then also there will be interaction and transfer of energy and momentum is possible. In the topic collision, we study about the two bodies coming closer or even touching each other, interacting with each other, such that there is transfer of energy and momentum between them. In the collision, in the all types of collision, we find there is conservation of momentum. But for the conservation of momentum, one thing is very common and self-imposed, that there should be no external force. When we deal with the collision, we do not consider the external forces like friction, viscous, and all that. Two bodies are colliding, momentum will be conserved, doesn't matter what is their size. Means this law is independent of their size. True for collision of two nuclear particles. At the same time, this is true for collision of astronomical objects. Now, in collision, these particles may change or may not change. Both the possibilities are there. If the particles change after collision, that means the reaction has taken place. If the particles do not change, this whole process is known as scattering. In scattering, only the direction changes, but in reaction, any change might be possible. And then, in order to study collision, you see, on the same footing, on the same line, we study explosion also. So better to say in general that in order to study collision and explosion as well, we use the term coefficient of restitution. It is represented by letter E. This is equal to relative velocity. You see, V means final, means after collision. This is the difference of velocities after collision, difference of velocities before collision. You might say it is the ratio of relative velocity after and before collision, but in opposite direction. Minus sign indicates here that if you are writing u1 minus u2, here you'll write v2 minus v1. This is what we call coefficient of restitution. You must remember, he is frequently used by you in electricity, in mechanics, and even while dealing with radiation chapter, relative emission, that's also represented by small e. In mechanics also we study this term E, but here this is coefficient of restitution. E has different values for different types of collision. This is simply the ratio, it's not going to have any unit or dimension. Coefficient of restitution we came to know. The foremost application that we are going to make here is that in explosion. But to be alert, we are not talking about nuclear explosion. That's very dangerous and gigantic energy is liberated over there. Here we are dealing with chemical and mechanical explosion. Why I am restricting our discussion to these two? Because in nuclear explosion, some theory of relativity and other things are also involved. In chemical explosion, or even by hitting these celebrating bombs, these explode by hitting simply, that will be mechanical explosion. In these explosions, there is one object. Normally we call it bomb or firecracker. This gets exploded in 2 parts, 3 parts, sometimes even in multiple parts. See, when it was at rest, it had no momentum because the velocity initially, u, it was 0. Whatever be the mass, but the momentum here is 0. This gets exploded in 2 parts, then both will have the velocity, both the parts 1, parts 2 I have made on either side, just keeping in view the conservation of momentum, because they are going to move in opposite direction for keeping the momentum conserved. So one goes this way, other goes this way. Their total momentum shall remain 0. Why? Initially it was 0. Then two things making the total value 0 means they are opposite to each other. This is the analysis, momentum analysis of explosion. But you think in terms of E, for all the explosion, E is greater than 1. For all the collisions, E is less than 1 or at the maximum equal to 1. But in explosion, we are saying that E is greater than 1. What does it mean? There is increase of kinetic energy. How is it possible? This is one firecracker. Now, it is placed at rest, no kinetic energy. When this is exploded, both the parts will move, means there will be kinetic energy. Initially it was not, now it is there. It means kinetic energy. 0 kinetic energy initial value, and finally it has got some value, means kinetic energy has increased. Where from does it increase? Chemical energy has been converted into